Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with congruent triangles. So in the previous sections we looked at identifying quadrilaterals given the information about their sides, angles and diagonals. Now we're going to go on to page 132, which is congruent triangles. Okay guys, you've met congruency already in grade 8. We talked about what is congruency, what is similarity. Now we're going to run through the 4 possible cases for congruency, okay, or congruency in triangles. All right, so I'm on page 132, right at the top. Okay, so triangle ABC is congruent to triangle PQR. Okay, so I want you to follow me in the textbook on page 132. If angle A equals to angle P, angle B equals to angle Q, angle C equals to angle R, and AB equals to PQ, AC equals to PR, and BC equals to QR. Alright, so basically what that's saying is that two triangles are congruent if all of their angles match up and all of their sides match up, meaning the sides have to be exactly the same. Okay, right. Let's continue. So it is easy to identify congruent triangles if all the sides and angles are known. The real challenge lies in establishing the minimum conditions for congruency. Right, let's continue. So it is easy to identify congruent triangles if all the sides and angles are known. The real challenge lies in establishing the minimum conditions for congruency. Okay, so that is the important bit, is that yes, if we have two triangles and we have all the info in those triangles, meaning all the angles and all the sides, it's very easy to match them up and say, are they the same or are they not the same? But what they're trying to tell us here is that what are the minimum conditions, or what is the minimum amount of information, and which information do we need in order to conclude that the triangles are congruent? Okay, and that's what we're going to do. We're going to go through case by case and see what they say. Although triangle DEF and triangle GHI are equiangular, they are not congruent. So now we're looking still on page 132, the two triangles, one which is drawn inside of the other one. What they're saying here is that the angles are all the same, they match up, but the sides are not equal, which means that the two triangles are not congruent. Okay, they are similar, and we'll talk about similarity in the next section. Congruence cannot be proved without at least one pair of equal sides. Okay, so that's one of the conditions that we'll cover. Right, so let's go to congruency case 1, which is side, side, side. So the abbreviation there, SSS, represents that the three sides of the triangle need to match up, and then we have a congruent triangle. Okay. So what they give us is they give us three triangles over there. They use the bars to indicate that the sides are the same. Okay. Triangles with three pairs of equal sides are congruent. Order matters. Okay. So in which order the sides go. So if triangle PQR is congruent to triangle KLJ, then it implies that angle P equals to angle K. So you have to exactly match up the letters the way it's written in terms of the letters in the triangle. So meaning that angle P equals angle K, angle Q equals to angle L, angle R equals to J, and the sides match up as well. So an easy way to do this, to not get lost which sides we are talking about. So let's say we have triangle PQR and triangle KLJ. Okay, so those are our two triangles. If we are told that these two triangles are congruent, that means angles and sides match up. So basically, for the sides, you're just taking any of the two letters. So let's say I take these two letters PQ, okay? That means that PQ, so if these two triangles are congruent, okay? This triple equal sign with the three bars going across means congruency, okay? So it means that this triangle is identical to this triangle. Also, PQ equals to KL, okay? Then if we take QR, that will equal to LJ. So QR equals to LJ. And then if we take that letter and that letter, so PR equals to KJ. All right, let me use another Koki. This one is not very visible. I'm sure you can see that though. All right, so the order matters. Okay, so use the triangle letters to match up the angles and the sides is what I'm trying to say. So that it doesn't, so you don't get confused into which one is which. Okay. Right, so the first case is basically saying that if I give you 3 sides of a triangle, 3 lengths, then the triangles are the same. Okay, because you can't draw me a different triangle with identical sides. Okay, so if I say to you that if we have a triangle that looks like this, let's say, okay, and the sides are 1, 2, and 3 centimeters, right? Then I tell you, right, draw me another triangle with also sides 1, 2, and 3 centimeters. The only triangle that you can draw for me will be exactly a triangle that looks like that, because you can't have 3 of the same sides give me a different triangle. Okay, because remember from our scalene, isosceles, and equilateral triangles that the distance of a side is related to the angle. So if I give you the 3 sides, the angles are already essentially predetermined given those sides. Okay, so what I mean to say, let's say I try to draw a triangle with sides 1, 2, and 3. So if I start from this point and I draw a side which is, say, 2 this way and a side which is 1 that way, okay? And the other side is a 3. There's only one way to fit another line here, which is exactly 3 centimeters, okay? Basically meaning that we can have these 2 sides, okay? And when we draw them, we can open them up further like that. There's no problem with that. But the third side needs to be 3 centimeters. So it will only fit into one triangle that is possible. Okay, so if I'm given 3 sides of the triangle, that determines congruency. Okay, so if I have a triangle like that, and let's say another triangle like that, and it also says 1, 2, and 3, well, these 2 triangles are exactly the same. Okay, so that is known as side, side, side. So when you prove congruency, you have to tell me which congruency condition have we used. And here it is side, side, side. Right, let's go to the next one, congruence case 2, which is side, angle, side. If 2 pairs of sides and a pair of angles are given, triangles are not necessarily congruent. Okay, so it says if 2 pairs of sides and a pair of angles is given, they are not necessarily congruent. So this was one of the exercises that we did when we had to construct a triangle, and there were 2 options when we could do that, and it made either a triangle like that or a triangle that was a little bit shorter. Okay, I can actually tell you on what page that is. Give me a second. Okay, so it's on page 116. So if we look at that construction over there, that's exactly what we are talking about. Okay. All right, let's get back to congruency. So, in triangle ABC and triangle ABD, okay, so triangle ABC and ABD, right, let's see. If 2 pairs of sides and a pair of angles are given, triangles are not necessarily congruent. So, let me draw this. So we have a triangle that looks like that, and we have another line doing that. Okay, so this is A, B, C, and D, and that equals to that. Right, that is that. Okay. Now in triangle ABC, and triangle ABD, What we are trying to show is that we have one, AB is common. Okay, guys, what we're doing here is we're trying to prove that triangle ABC is congruent to triangle ABD. Okay, and we're going to see that the condition of side angle side has to be very specific in order for congruency to hold. So remember, side angle side needs to be the same. So what we have here is that AB is common to both triangles. Okay, this angle B is the same, and we have another side, AC and AD. So AB is common, number 2. B, angle B, is 25 degrees. So this is 25 degrees, and it's common for both. Right? And number 3, we have AC equals to AD. So we've shown that we have a common side, we have a common angle, and we have another common side. We've met the criteria, but what we notice is that this triangle is definitely not the same as the bigger triangle. Okay. What they're trying to tell us is that the side angle side condition has to be very specific. Okay, what I mean by that is the next example. If we look on the next page, triangles with 2 pairs of equal sides and a pair of equal included angles are congruent. Okay, the key here is the included angle. Okay, what is the included angle? Remember, we looked at this in the previous sections when we constructed. Okay, an included angle is an angle between 2 given sides. So let me take this off. So if I have a side that's the same to another side of a triangle, so these two are the same, and we have an angle over here and an angle over there, and we have another side which looks like that. So if we have 2 triangles and we match up that one side equals to the other side, an angle is the same as another angle, and this side is the same as that side, we can prove congruency. The included part means that this angle is wedged between a known side and another known side. Okay, so when you write the abbreviation side, angle, side, you can already see that the angle needs to be wedged in between of the 2 known sides. So in the previous example where we showed that we matched up side, angle, and a side, but the angle wasn't an included angle, okay? Because we had, in the previous triangle, we had this situation. We had this angle, we had that side, and we didn't have this bottom side. We had another side over there. So the angle was not included, was not in between of the 2 known sides. That's why congruency didn't hold there. So for the second congruency condition, we need to have a side, angle, and a side. And the angle needs to be included, meaning that it's between the 2 known sides. Okay, so that is our second congruency condition. If we look at the diagram on page 133 at the top, that's exactly what we have. We have one blue side matched up, we have an angle in between that is the same, and we have another side that's matched up. Okay, now that will produce congruency because think about it. If we have everything the same, the only missing side of this triangle is that. And this line will be exactly the same as this line because simply it has no other option not to be, because these 2 lines are already fixed in position, the angle is there, so all you left to do is just join that one line, which will be the same. Okay, so to prove this congruency, it's side, angle, side. Right, let's go to the next one. The next congruence case is angle, angle, side. Okay, the way they write it is angle, angle, side. I like to write it differently. I like to write it exactly like this because it tells me that I have to have an included side. So angle, side, angle. So the side that I have needs to be included or wedged between the 2 known angles that I have. Okay, so let's do another example for that. Right, so we have angle, side, angle. So I need an angle. Okay, so there's my angle that I have. Okay, then I need the included side. So this side needs to fall between an angle and a side. So this is the side that I have, and I need another angle. Okay, do you see I need this angle? So if I match up this information with another triangle that has exactly the same setup, this angle and that angle and a particular side, that's enough to prove congruency. Why? Well, because we have these two angles. So if we just extend this line up, extend that line up, that will give us the third point of the triangle. There's no ambiguity here. It can't be anything else because these angles are fixed and that distance is fixed. Okay, so the same thing over here. These two triangles will be exactly the same. Okay, so the most important part here is remembering what are the four different conditions, and they're very easy. It's side, 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 or side, angle, side, with an angle being wedged between the two known sides, like we did before, or we have a side that's wedged between the two known angles. Okay, so it's always an included side or an included angle to prove congruency. Okay, so that is our third case for congruency. Okay. And the fourth case for congruency is RHS. Okay, so RHS stands for right angle, hypotenuse, and a side. Okay, whatever side. So to prove this congruency condition, this applies to right angle triangles. Okay, so what I need is a right angle. So let's say we have a triangle like that and a triangle like that. So first condition, we have an angle that's 90 degrees. There it is. Second condition, we need to match up the hypotenuse. Okay, so the hypotenuse needs to be the same. So that is the hypotenuse. That is the hypotenuse there. So those two, and remember, hypotenuse is easy to identify because it's the longest side in the right angle triangle, or it's the side opposite the 90-degree angle. Okay. And then the other piece of information that we need is a side. Now this side doesn't have to be included anywhere. It's just another side. Okay, so it could be this side equals to that side over there. Okay, so we need a right angle, a hypotenuse, and one of the other two sides. Okay, if we have that info and we've matched that up, we have congruency condition. Okay, and that is our case number 4. Alright guys, so those are the three congruency conditions that we have. If we look on page 134, we have them summarized for you there. The only one that I like to change is the AAS to ASA, because to me it makes sense that it has to be in the middle and it's got to be included. Okay, that's how I remembered it at school. Right, let's look at the worked example on page 134. Name 3 pairs of congruent triangles and state the case for congruence for each. Sketches have not been drawn according to scale. Okay, so we need to name 3 pairs of congruent triangles. So there are 6 triangles in total, so they're obviously going to match up exactly. So let's try to match them up. If we look at triangle ABC, what is given there? They've given us the 3 sides. We have AB, AC, and BC, and the markings indicate the same sides. So now we need to find another triangle that matches to those 3 sides. Remember, if the 3 sides match up, then those triangles are congruent. So if you have a look here, I can see that triangle JLK is the same as triangle ABC because they match up the 3 sides. So we can say that. So we can say that triangle ABC is congruent to triangle JKL. Okay. Now we need to say why it's congruent. Okay, what is the congruency condition that we used? Well, the one that we used is the matching up of the 3 sides. So the condition is side, side, side. Okay, that's all you're going to write for me. Okay, this bar basically creates a break between your statement and reason for the statement. Okay, let's look at the next triangle, DEF. Okay, what do I have there? I have the two sides that are given, and I have an included angle, which is angle X. So what I need to find is another triangle with the included angle X and the two sides that match up. So you're matching up the bars on each side. And what I can see is that angle EDF or EFD or DFE, so triangle DEF is congruent to triangle MNO. So I keep forgetting the triangle MNO. What is the condition? Well, look at the information given and read it in a clockwise manner. So it's side, angle, side. Side, angle, side. We have the included angle between the two known sides. Great, so we've done 1, 2. Let's look at the third triangle, GHI. So triangle GHI is congruent to what triangle? Well, GHI has what? It has a 90-degree angle, it has the hypotenuse and one of the other sides. Which other triangle has the same? Well, they've actually color-coded these triangles for us to make it easier. So the green one corresponds to the green one, which is PQR. Okay, triangle PQR. What is the congruency condition for here? Well, it was the right angle hypotenuse side. RHS, right angle hypotenuse side. Okay, guys, and that's how we match up these triangles. So what I want you to do is exercise 13.6. Okay, so get 13.6 done, and that will be it for now. In the next lesson, I'll continue with the worked examples and more complicated problems in congruency. I'll show you how to exactly solve them. And you guys are going to try exercise 13.7 tomorrow or the next time I have a video lecture. Okay, thanks guys. I hope you enjoyed it, and I'll see you next time.